All right. With that, I'm going to hand it over. You're already logged on to Venkat Viswanathan, who is also a faculty member at the University of Michigan. He's a professor of aerospace engineering, and he is primarily running the next 2 to 3 weeks. And he's going to be talking about broader goals, and he's going to share the agenda and go into some of the details that I didn't touch upon. And the last thing I wanted to say is we hope for this, we expect about 100 people participating. So please, and this will be successful if we have an interactive discussion. And the way to do that is to use the Q&A tab. So at any point of time, if you are thinking of anything, please go ahead and use the Q&A option. And we will moderate it and bring up the topics for discussion. All right, with that, Venkat, up to you.
All right, thanks, Karthik. Okay, welcome everyone to SciFM24 Summer School. Very excited to have people from tuning in, I guess, from all over the world. And then I think excited to see all the people in the room here in Ann Arbor. So first I want to thank Karthik's support here. MICD has been a real leader here in setting up the SciFM vision here, actually led by a Catalyst Award that was funded by MICD last year. And then sort of, as Karthik showed, right, a lot of exciting things have happened. I'll just give a quick shout out to Argonne and Los Alamos that have provided support. And then special call out to Arvind Ramanathan from Argonne, who's been deeply involved in co-organizing a number of the tutorials that you will hear about in the coming week or so. Okay, so I'll run through sort of the goals of the program. So the main goals of the summer school are fivefold. The first one is for this vision that Karthik showed in terms of various pieces that are involved in training, pre-training, adapting it to downstream tasks in different scientific domains. The goal here is to try and do that in detail, so develop very detailed technical plans for specific instances of SciFMs. And so the general vision here is that if you see the speakers that we've curated, they are covering a wide range of topics around issues related to material science, chemistry, biology, and various aspects of being able to do computational simulations, computational science agents, as well as being able to understand very large scale image and video scale data, and initial steps towards PDEs, where this is sort of seen much less success than other topics that we talked about. So today you'll hear about sort of state of the art, and then we'll use that as a springboard to develop further in terms of what are the holes. And then the format is very much informal, so we want to talk about the problems just as much as the successes. So you'll hear from the speakers giving an honest appraisal of where things are. The next is a hackathon. The hackathon is intended to build a very strong community of learners and builders who are going to be involved in working on specific instantiations of this SciFM. And I'll talk in a little bit about the 4 categories and the leads and how we plan to run that. And then we hope this summer school acts as an incubator of ideas. Already, from the attendees that have signed up, it's clear that we have a diversity of topics that people are interested in. So we hope that the methods that you learn here at the summer school are broadly useful and you go and use them in your own domain. Most importantly, I think serve as a training ground for researchers and students. This, as Karthik mentioned, this field did not exist a year ago, right? And so it's very important that we can adapt and provide material such that students and researchers, right, can very quickly get up to speed and be able to work in this area, as well as being able to provide access to cutting edge computational resources. Here, we have a number of resources that we are going to use during the hackathon phase, with reserved nodes at Oregon, Los Alamos, and to be able to test, right, the development of these models, and learn how to sort of deploy them in practice. And the last piece is we're going to try and use this to build the SciFM ecosystem. This was another one of the agenda points that emerged from the SciFM conference, to bring together researchers across the community, to sort of bring hundreds, if not thousands, of researchers together across disciplines to be able to move towards this SciFM ecosystem. So we're going to have a visioning session later tomorrow, and then we'll hopefully at the end of the summer school present a vision for how to take this forward. Okay, so very briefly, right, I'll provide the agenda at a glance. Okay, so there's a number of exciting topics that we have. So the first week is going to be fully hybrid, so people can join here in person or in Chicago or online. And the first 2 days, so today we will have an overview of the state of the art. So today morning we'll have a keynote by Ian Foster, and then in the afternoon we'll have some of the success stories that we have seen on SciFM for various domains. And then tomorrow morning we have a session from a DARPA program called FoundSci, where the PIs will present their progress towards incorporating inductive biases from scientific disciplines into foundation models. Then Wednesday through Friday, we have a number of tutorials. Wednesday morning, we have a tutorial on PDEs and weather foundation models, so how to handle image and video type data, and as well as how to design architectures for foundation models for partial differential equations. Then in the afternoon, we have a tutorial on data and tokenization. Here, the specific data stream that we'll focus on is sequence data. So we'll talk about omics, so a lot of aspects in biology, as well as molecular data, SMILES, selfies, and then how to tokenize this. And here we'll talk about unique aspects of challenges that science presents that will be different from the context of vocabulary. How do you sort of think about tokens in the context of these kinds of molecular data and so on. So that will cover tutorial 2. So tutorial 3 will talk about various kinds of models. And here, we'll talk about sequence transformer, vision transformer, diffusion models. And then in the afternoon, we'll talk about a very important aspect that has sort of really revolutionized the field of foundation models, which is scaling laws, and talk about the origin of neural scaling laws and how you can use that and leverage that to build compute optimal foundation models. And then finally, we'll close on Friday with a tutorial on agents, as well as a final summary of where the state of the art lies in terms of both language models as well as agents in the context of chemistry and biology. Okay, then that sort of ends the fully open portion. Weeks 2 and 3, we'll have a deep dive hackathon, and I'm going to talk a little bit about in detail what that will entail. And then in the midst of that, in week 2, we have the 5th tutorial, which is on AI accelerators. This will be led by Venkat from Oregon, and we'll have a number of vendors sort of talking about the latest and greatest in terms of work going on in AI accelerators, both on the training side as well as on the inference side. And then on Friday, next Friday, we'll have a tutorial on federated learning, where we'll show learning across multiple computing clusters and sort of showing how you can perform a training task across this. And then the hackathon continues, and then we'll have a report out from the teams at the end of this week. And then we have a closeout session that sort of tries to wrap this up and then sketches out the plan for the future. One more thing before I sort of hand over to sort of Ian Foster for the keynote is hackathons. So we have 4 specific hackathons. The teams have largely been formed. So the materials trust, I will lead this. And so the goal here is we will have teams working on molecular data. Models that leverage latest advances like Molformer and some of our own work with MIST, and use that to test various kinds of issues related to tokenization with respect to some downstream tasks. And then Arvind is going to lead the biology thrust here. The core foundation model is their pioneering work on GenSLM. And they will use that to sort of do a number of tasks, downstream tests associated with leveraging GenSLM along with other kinds of computational tools. Next one is computational science agents. Here, this is led by Jan Jansen. Jan actually built this tool called LangSim, which essentially builds a foundation model with which you can generate computational science agents. So it generates code and workflows and executes them. And he's shown that it can actually do very well for problems in material science. He showed that it can use that to run simulations with one espresso and various kinds of things. So the hackathon here will try to build that and then try to use that to automatically develop training data and train a machine learning force field. And so fully automatically with this sort of foundation model. So very, very exciting frontier. And I think one that is, quite revolutionary if this actually works. And then the last one is PDEs led by Karthik, and also Anima's group is very strongly involved, and Siddharth Mishra from ETH as well. And so again, as Karthik mentioned, right, if you're interested in participating in the hackathon, we're mostly finalized, right? So if you're still interested, right, feel free to reach out to us about this. Okay, with that, I can introduce it. Yeah, I'll hand it over to Karthik to handle the first session. All right.